We humans, we have a little problem. Our short-term memory is limited. So if this is my short-term memory, it's limited to five to nine elements. Okay. Let's say 7 in my case, for example. So 5 to 9 elements that I can remember short-term simultaneously. It means that, for example, when I read a book, I can only remember the last 15 seconds I read. For example, when I'm at the end of the page, it's almost impossible for me to remember word by word the first line of the page. It's lost, it's out of my short-term memory because I had to free it to read the next line. So it's very annoying because thinking, the process of thinking is to manipulate informations consciously in my short-term memory together with longer-term informations. So because of this limitation, I need to free my short-term memory by transferring items, informations or know-how in my long-term memory. For example, let's take this equation. Let's say it's a fraction of fraction. Okay, so it might seem very simple or very complex according to what I know in my long-term memory. For example, if I know by heart that 5 by 7 is 35, I can immediately see that this can be simplified. But if I don't know fractions, for example, so that would be multiply. If I don't know the notion of fraction, if I don't master the notion of fraction, that I could simplify this, I will have a hard time to figure it out. If I don't know the notion of power here, x squared, that's another notion I have to use for solving this. If I don't know that this is equal to x plus 1 squared by heart, because I learned it, it's in my long-term memory, I will have a hard time to figure it out immediately. That I can simplify this by this by this is 5, and this can be goes to the other side if I flip the fraction, and then the plus 1 can go to the other side if I flip the sign, and it's minus 1. So everything is very easy to me because I master all these small elements. They are not in my short-term memory. They are in my long-term memory. So a pupil who does not master all these elements has to fill his short-term memory with it, with the teacher reminding, do you remind 5 by 7? Okay, it's my short-term memory. Do you remind how powers works? Okay, I put it in my short-term, and very soon the student is overwhelmed with this equation. It's too much. So the only way to be able to do that is to have thrown, a long time ago, thrown away these notions in your long-term memory. and to free then your short-term memory. And that's the first function of the drill. It's to integrate, to automate. Automatically, I recognize this can be simplified. Automatically, I recognize this is x plus 1 squared. So, it's not enough to understand. And usually, pupils are confused because they understood once that this is 5. But they did forget. Simply as that. They didn't manipulate it enough. And so it's not here. It's like if I can see Lionel Messi playing football, playing soccer, and I say, okay, I understand how he plays football, but it doesn't mean I can play football as good as him, all right? For example, with karate, if you want to be creative during a combat, you cannot think about every single element, like how should my fist be? Is it like this or like this? Is it like this or like that? Is it here? Is it here? Is my whip going to participate in the movement? Where are my feet directed to? Are they like this or like this? My shoulders, my side, my head maybe too much up front. So yeah, if I master everything, I can then think about my opponent. I can use my short-term memory to think about where am I going to hit, how is he moving, and so on. Am I going to use my foot? If I wonder how to use my foot, then I'm overwhelmed with the combat. It's the same for mathematics, it's the same for football, it's the same for everything. If you want to progress, you have first to integrate the basic building blocks. So that's the first function of the drill. The second function of the drill is to fill the gaps. For example, I'm 13 years old and I'm supposed to be able to learn that, or I'm supposed to be able to do that by now. But I don't know that 35 divided by 7 equals 5. So I should first train on that, because that's one of my gaps. And it's not very useful for the moment to train on this. So I should skip this for the moment, leave it for later, and refocus on this, even if I was supposed to do that 5 years ago. When I was 8, now I'm 13, for example, I'm going to retrain on that, so I put it in my long-term memory with a drill. And that's in my proximal development zone, which means it's hard enough to be challenging, but it's achievable. And it will make me grow. And this is the basics of motivation. If I cannot do this, I will give up on this very quickly. And I will not be motivated, and I will have, and my teacher will have a very hard time with me at school, probably. So, during the drills, every student has exercises to his own level. So maybe everyone in the classroom is doing computations at the same time, but let's say this is level 3, and maybe in 2 weeks I will be level 5 and do more complex computations. Okay. And this would be, for example, level 30, if you like. So maybe a friend of mine, a teammate, a classmate, will be level 30 and I will be level 3 for today. And it's okay. It's not a competition. It's just doing something useful for me according to the gaps I have. Freeing my short-term memory from that, putting all this knowledge into my long-term memory, integrate it, so I don't have to think about it. It's like if you run a bicycle and you don't know how to run a bicycle, it's your first time, you are scared, you look everywhere. Is there a dog approaching? Is there my phone is ringing, is ringing, oh my god. No, if you are an expert at cycling, then you are on your bicycle, you see a dog, you just don't even think about it, you move so you don't collide with the dog, your phone rings, you answer, maybe you can still bike at the same time. It's not a problem. Okay. That's it for the drills, I think. No, that's not it. That's it for how it works in the brain, but how it works in the classroom. Typically, I like to work with 5 minutes drills. So let's do this kind of computations for 5 minutes, many computations as fast as possible. Everybody is doing hard work silently for 5 minutes on computations. Some level 3, some level 30. And then, when that's done, 2 minutes with a more relaxed atmosphere, when students can talk with each other, for correcting. Yes, I need to look if my answers are correct or not, and to identify those which are not correct, and to understand why it's not correct. Let's give students 2 minutes for that. If I need a longer explanation, I will not do that during the drills. I will not ask questions to my teacher or to other students during the drills. I will do that when the hour of drill or the 10 minutes of drills, for example, are finished. And maybe I will go into a separate room and get some private explanation about a specific computation I could not understand. And then maybe 2 or 3 days later, I can move to the next level. That's for the drill. Thank you for listening.